Okay, I'm going to quickly repeat myself again. Basically, we're going over question 4. Last time we went over question 3, and we're just kind of being like, all right, in the case that like you don't have a very specific ask to look at, where like Uniswap v2 had just one event and one function call, right? And if I have like a pair contract, and we're going to go over the pair contract, it's like, how do you figure out what to look at first, right? So let's dive into it before I waste any more time. So in this case, I think for pairs, what a lot of people struggle with at the first start is like, how do you even find the address of the pair you're looking for, right? Because like if I go to Etherscan and try to type in like USD/ETH, it's like not super clear how to find it all the time. I think there is like a way to do it, but yeah, like it doesn't really work well, right? So in this case, you have to go to Uniswap. They have like an info. Hold on. I actually forgot to let Uniswap pools. Info.uniswap. All right, it's this link. And this is gonna show like all of their pools, and then you can go do like, oh, this is V3 Analytics, so you have to open V2 Analytics, as we're looking at V2 right now. And we're just gonna look for USDC ETH. But that's not looking. All right, this one. And then from here, somewhere in here, links out to Etherscan. There we go, pair address down here. That's probably the fastest way of finding a pair address. And I'm just gonna double check that this is right. Let me just look at like a swap and just double check. Yeah, they have this swap here. You can see there's actually two swaps. So in this case, they were probably swapping set for USDC, and we're going to go over this later in routers, but essentially the route path was swapping for ETH and then swapping ETH for USDC, I believe. Yeah, we'll get back to that. But anyways, that's the easiest way to find the pair. So now we have a pair address, and we're going to stick it in there. So let's do top logs first, right? So top logs. Logs where contract address equals this, right? We'll just do another 10 to make this easier. So again, for the logs table, the contract address is the contract that's emitting the log. The topic one is all the topics in Dune are like one, like they're like indexed by one higher than actually on chain. So topic 1 is actually topic 0, topic 2 is actually topic 1, topic 3 is actually topic 2, and data is just data. And if I just pick an example transaction hash, then you'll be able to see that it's like, okay, within logs we have our contract address somewhere in here, right? So like this is the address that's emitting the event. There's a transfer event, there's a sync event, there's a mint event. And there's these other events you can see here that are emitted from other contracts. And we're going to get into that later. But for now, let's start basic, right? Let's just say we want the most common topics. So let's just take topic 1, count as times emitted. One, five, two, so very basic level, this is top logs, right? For like getting emissions. But something you probably commonly want for this is like, okay, it's not useful for me to just see what the logs are. I want to see examples. Um, so what we want to get to is the topic, the times emitted, and then an example transaction hash. There are a few approaches to this. I would say probably the easiest one is just doing like a max on transaction hash. Um, I think I did mention here like I have utility queries, and the fastest way to find that is just if you search up like a user and then look at their queries, and then you can search their queries. Um, I think I call it like event sleuthing or something. Yeah. Um, so I went for a fancier approach here in terms of like you use row number and then partition for the count, like a cumulative count basically. And then you only take the row number of the most recent transaction, since that's also going to be the highest cumulative count. But max works just as well, so we don't need to do that. um, what I will do to make our life easier is let's change this into like an HTML link that's easier to click, so we know that transaction has this format, right? So let's do this, and I'll do concatenate just because it's more readable for now. So we're going to concatenate this link with the transaction hash. Um, and then we're going to do this. Link. Does that work? Alright, hold on. I need to replace text, change it from this to this. Now we can take the max. Okay, I'm gonna cheat and look at my other stuff. Because I always mess up. Oh, right. I always forget this. What did I mess up? Alright. Let's start with this one. Does it not like me doing max? Oh, it didn't like me doing max there. Or, oh no, that's not the issue. Sorry, I'm still waking up. I'm missing a parentheses. Alright. So we can run this and we can get the top logs, how many times they're emitted, and then we should get an example transaction. And this normally makes it easier to look at. You can do the same thing with functions. So in this case, right, we would do top functions select. Remember that every transaction has a data field, and that data field is where like the function input is put. Alright, so we're going to substring this, take just the first 4 bytes as funcsig, and then everything else is the same, right? This times emitted, and hash. Apple from Ethereum.transactions where where 2 equals. Alright, so in this case we're looking for the contract call. And we need to do this one more time for internal calls. Alright, and this will make sense in a bit, but we're gonna do traces. And I should actually do a comparison here to make this make more sense. Right, so let's compare across event function traces. Right, so if I do distinct this will make sense in a second. Transactions. I hope this doesn't time out. So basically here I'm seeing like distinct transaction hashes from the events, from the traces, and then from the transaction calls. And you'll see that the distinct is actually very, very different. I'm going to take this and run this in a new query so we can not be sitting around here just waiting. Let's see. I actually wonder if this one might be faster than the new engine. Let's find out. So in this case, in the new engine, I don't need these to be slashes. I don't need the quotes. Don't need this quote. Remember, the new engine is Spark SQL. So we'll see if that runs faster or not. But alright, basically, point of doing this, and hopefully I can show it clearly once it finishes running, is you can sometimes see, like, if transactions 2 is higher than traces 2, then, like, this contract is, like, your main interaction surface. If traces is higher than transactions, that means, like, it's more of, like, a logic layer contract, or, like, base layer contract, and there's, like, levels of abstractions built on top of it that, like, people call. So, like, that kind of gets into the composability side of things, but it's kind of good to know of, like, okay, is the contract I'm looking at, like, the main thing, like for Aave, it was, like, lending pool, right, was the contract we were looking at the last 2 weeks. And, like, that one would have a much higher transactions to than, like, traces to, right? And that's because, like, that's the main surface. But Uniswap's built in a way where essentially it's, like, factory creates pairs, but, like, all of the users interact with something called a router, which then interacts with pairs. And one of the reasons for this is, like, if you remember the transaction hash we were looking at earlier, where it wasn't this one. It was where they had, like, 2 swaps in there, where it was, like, swapping xset to ETH and then ETH to USDC. That's, like, a routing path, right? So the router essentially figures out the path that you should be swapping things in. So because of that, whenever you swap in Uniswap's front end, it goes through the router, right? And if you have any sort of, like, aggregation layer on top, then it's going to be, when I say aggregation layer, I mean something like 1inch or Matcha or like 0x. Those are, like, routers that include all dexes. So, like, it would include Curve, it includes SushiSwap and whatnot, and not just Uniswap as, like, part of the route path. Okay. Don't think this is going to load for a while, so we're going to move on. That's going to be some of the problems we run into as we go through later practice questions. It's going to be a lot of, like, waiting. Trying to think if there's anything I can go through while we're waiting. Oh, yeah, okay. I did have this bonus question. It's worked out in my queries if you want to take a look. I think I did. This one's probably more useful, the function order sleuthing. So every single contract that's decoded in Dune is going to live here. Hold on. Did I hit my query limit? Is my Wi-Fi working? Can y'all hear me? Not sure if my Wi-Fi. Oh, okay. Maybe Dune is just. Oh, okay, there we go. Now it's running. All right. So if you're curious, like, oh, there's some sort of, like, I think we looked at this in question 2. This is like one of the bonus questions. Is like if you have a bunch of random contract addresses and you don't know what you're looking at, then you can always join them against Ethereum.contracts. And if it's a popular one, it's probably decoded, and you can get like what is the name of the contract and like what's the namespace or protocol that deployed it, right? So I'm not gonna go through this query, but essentially it's doing what we did here with just this like easy aggregation and example sort, but now it's like the order of calls matters, right? So it's like I think there's quite a few approaches to this. I just did basically like for each user, what are all of the functions they've called, and like order it over time, and then once you have that order, then you do like an array aggregation. So you have like for each user, what is in an array, what is the order that they call things in, and then you take that array aggregation and start doing a group by, so you can see how often are different action orders taken, and then these are like the example transaction hashes that go with it. It would be nice if, like, I think they're working on it, but once Spark has like UDFs in Dune for like KACAC 256 hashes, then we could be fancier and like hash the ABI from Ethereum.contracts to then match on the function signatures and like change this to the name of the function rather than just like this unintelligible 4-byte string. And if we have that, then we can literally start building amplitude within Dune into like a full dashboard. I think that's where I want to take this. But for now, this is just a practice question. I think it's good SQL practice to try to build it. So I think on the contract side, this isn't too complicated. But that's that. All right, this finished running. So we have 2 main topics here that seem to be emitted a lot. So I'm going to click the example link. I wonder if I should have done min here. I don't think it really matters. Because this was, okay, 337 days ago, yeah. So we can go to the logs here, and just for sanity, I always usually check what the function being called is, and then like making sure like what the contract is. So in this case, you can see it's the router being called. It's not the actual contract. But I'm going to take this topic and just do this to see, okay, this is sync. All right, so like it's like I don't know what sync is, but I might want to keep in mind this for later. Vsource, what does this do? Oh, it's just okay. We're gonna come back to that. And then there's this other one that's been emitted almost equal amount of times, and that's swap, right? So that makes sense. This is swapping some amount of tokens to get some amount of tokens out, right? So that's not surprising that those are the 2 most common events. Now I'm going to look at this example link, and once you've looked at contracts enough, you'll actually recognize this topic. Bonus points for whoever can identify what this topic is before I search it. You have 2 seconds. It is the transfer topic. All right, so this makes sense because if I'm swapping tokens, then that does mean I'm transferring tokens from like into the contract, and the contract's transferring tokens out to me, right? So a swap should have at a minimum 2 transfer events, right? So that makes sense. Oh, but then you might be saying, if there's always transfer events, then why is this times emitted much smaller than this times emitted, right? And the reason for that is because we're looking at the transfer events emitted by the pair address, right? So this gets into how are liquidity pairs stored, right? So essentially, whenever you add liquidity to a pair, and we're going to go through the V2 like solidity code in a second, so this will make more sense. But your position is actually managed as an ERC20 token, right? So you put 2 tokens in, you get 1 out that represents your position size. And then as soon as you like add more liquidity or remove liquidity, then that token is like transferred to you or from you, right? So that's the transfer event that's captured here. And that's why this is not as high as these numbers. But if I looked at like the USDC token or the ETH token, then I would expect to see at least this size of number emitted. Um, that's not a good explanation. Meaning, if I go to this link again, all right, and I look at transfers, you can see there's a few transfers in here, and I would expect these 2 addresses to be ETH and USDC. Yeah, so this one is USDC, 0xA0B, and this one 0xC02 is ETH, or wrapped ETH. And in case you don't know what the difference between wrapped Ether and Ether is, yeah, DD is very recognizable. In case you don't know the difference between wrapped Ether and ETH, ETH is like the native token of a blockchain, or the blockchain in this case, and it doesn't have concepts like contract or like emitting events and whatnot, right? Because it sits in like an opcode level, essentially. So to make things composable with like other ERC20 tokens, there's a wrapper contract for it, where you essentially deposit ETH and get wrapped Ether back, or you burn wrapped Ether and get Ether back, right? So whereas a typical ERC20 tokens like burn and mint, this one is just wrapping and unwrapping, and that's what ETH is, right? So, anyways, point being, I could take like what is the count of USDC transfers and count of wrapped Ether transfers from these transaction hashes, and it should match, basically. But this is the liquidity pool, right? And if I look at these last 2 transactions, which one was it? I think it's this one. We have approval, which isn't useful in our case. Approvals we're going to go over in a separate question. Okay, we have a mint. Here we go. So, minting. This means that someone added liquidity to the pool, and they're being minted this ERC20 token with a representation of like, this is how much of token 0 was put in, and this is how much of token 1 was put in, right? And that's like, when they redeem, then this is like what's given back to them, plus whatever fees they made, right? And this last one, I actually don't know what this last one is. This is, oh, obviously. Burn. This is when someone's removing liquidity. This is the amounts of token 0 and token 1 that they got back out, right? So just very quickly from that, I can see, all right, most people just use this to swap, and then there's some amount of people that are minting and burning, basically adding and removing liquidity from the pool. And then there's also a bunch of transfers where people are just transferring the token itself around, right? More than like mint and burn, this is like what, 60,000 total? So out of this 145,000 transfers, 60,000 of that is minting and burning, but that does mean there's still another like 90,000 transfers that aren't minting and burning, and that would be an interesting question of, and I'm going to add that as a bonus question, like why are there 90,000 transfers that aren't minting and burning, right? And the answer is liquidity mining, or farming, but or yield farming to be specific. But that should be a bonus question. Let's see. All right, that's a good practice question. So yeah, so like literally just from that, I'm already like, okay, that gives me like 2 or 3 things that I could analyze if I wanted to. And like honestly, that's like the most fun part of this is just like, all right, sure, I could look at like how much is being swapped and like where, like who's doing the most swapping or what. I could do like a singular event or function analysis. But the fun part of this like Web3 analysis is like there's always going to be something weird like this where you're just like, okay, the numbers don't really add up here. There's some behavior here I don't understand. I'm going to look into that behavior. And I like going that route versus just ticking the boxes. But it very much depends on what you're looking for. And that's something you can only really find if you like start with like the raw data, right? And this would be good timing if... perfect. All right. So coming back to this, all right, and remember this was just saying like how many distinct transactions are there where events were emitted from this contract, how many distinct transactions were there where the how do I say this? Where the pair contract itself was called, and how many transactions were there where the pair contract was called in an internal trace, where like another contract called the pair, right? And we can actually see that the number of times that pair was directly called is like only 19,000, versus the number of times that the pair is called by another contract is almost 5 million times. And it's actually also interesting that the number of times events were emitted in distinct transactions is less than the traces. That's actually not what I expected. I expected these two to either match completely or be very close, which means that there's some function being called that doesn't emit an event, right? Otherwise, like, for example, like, even if I have a router and the router's routing swaps, we know that swaps emit events because we already looked at it here that there's a sync event and a swap event, right? So this would start making me consider, like, okay, I want to look at the subset of trace transaction hashes that aren't in the log transaction hashes, so I could see, like, okay, what exactly is being called. Because, like, this means it's probably, like, a read function or a view function, right? Where it's like, okay, this is a bit cheating because I already know the contract, but, like, the router needs to know, like, if I'm swapping some asset, how much asset am I going to get out for the other token that I put in, right? So it's like a calculation call to this pair contract, which then tells the router, hey, this is how much you're going to get in and out, right? And that doesn't emit an event because that's something that's emitted on the factory, not the factory. That's something emitted on the router and not the pair. So it's like those read functions that show up in traces that wouldn't emit events. Again, that's kind of context you learn over time, but it all starts with stuff like this where you're like just doing some sort of sum query and you're just like, these numbers don't add up. Why don't they add up, right? And like this is definitely like a perspective you should try to take more and more, is just like what numbers should add up. Let me do those first, just to see if there's something I'm like really missing. So those finished running. Oh, and we can see that the V2 engine is faster than V1 because V1 took 14 minutes, V2 took 8 minutes. So great job, Dune team. This runs faster into V2. So I'm not going to run the rest of these, but you should run the rest of these and like click through the functions and the traces, especially the traces, because I think you're going to see some very interesting stuff. More on the traces side. I think the function side, you're going to be like, oh, okay, it's literally just swap, mint, and burn being called and transfer. Like that's probably going to match events pretty closely. It's just going to be the count is going to be much, much smaller because, as we already saw, there's only 19,000 direct calls to functions, right? So what might be interesting here is more just looking at who's calling those functions over time and like why would someone call the pair directly instead of the router. And the answer has something to do with mevbots, but that's something you should dig into. And yeah, traces, yeah, I would run this and look through it yourself. I think there's some pretty interesting things there. So that's practice question 4. Any questions? I know I've just been rambling. And totally cool if you don't have questions. Cool. So we covered which logs to look at. I should change this to be. Hold on. Okay, that's saved. Okay. Is there any caveats I'm missing there that might be helpful? There's logs, there's functions. There's a cross composability. We looked at the token transfers. Okay, I think that's good for that. Next step, I'm gonna restart the live stream, and we're going to look at basically the raw solidity code of Uniswap v2. And so that's going to be the router, and we're also going to look at this pair. All right. So people on Zoom, I'm going to be back in like 5 minutes. And then for the people on YouTube, I'm also going to be back in 5 minutes.